Hello everyone. Today I am going to discuss the sixth problem of AtCoder beginner contest 361, which is x equals to a to the power b. So the problem is quite straightforward. We are given a integer n, and we have to find the number of integers x less than equals to n, which can be expressed in this format a to the power b, where b is greater than equals to 2. So let's take one example, 99. Here you can see there are 12 integers which can be expressed as a to the power b, 1, 4, 8, 9, 16, 25, like that. Okay. So how we can solve this? Here you can see that the constants on n is 10 to the power 18. So now let's reduce the constants to 10 to the power 9. Let's say n equals to 10 to the power 9. Then how we are going to solve this? So if n is 10 to the power 9, then what we can do? We can iterate over every I from equals to 1 till I into I less than equals to 10 to the power 9, right? And what we can do, we can iterate over j equals to 1 and till I to the power j is less than equals to 10 to the power 9, and we can mark visited of uh, j equals to 1. Okay, and here we can take j equals to j into I hope you get it. This is the way to approach this problem if this is 10 to the power 9. Now what is the time complexity of this algorithm? The time complexity of the algorithm will be nothing but square root of n into log of n, square root of n into log of n. Why? Here you can see that the value of I is at max square root of n, right? The value of I is square root of n, and how many times j is getting multiplied. So let's take the smallest value 2. Okay, so we are multiplying it by 2 square, then 2 to the power 3, like that. Then we can say 2 to the power k is less than equals to n, then k is less than equals to log n. Okay, log n. So here you can see that if it is possible to solve this problem in square root of n log n, but here n is not 10 to the power 9. In the original problem n is 10 to the power 18. So this problem cannot be solved in this complexity, but we can definitely improve it. So let's say in the original problem we have to find a to the power b's, x equals to a to the power b's, where b is greater than equals to 2. B is greater than equals to 2. Let's modify this. Let's talk about b is greater than equals to 3. If b is greater than equals to 3, we can use the same algorithm. Instead of that, we'll use cube root of n, into log n base 3. The time complexity will be the same, and cube root of n log n base 3 will be the time complexity of this algorithm. With the given constants, this is definitely possible. This is cube root of n is 10 to the power 6 and log n is around 20, kind of. So this is possible definitely, but we are missing out all the square numbers. Okay, we are missing out all the square numbers. So what we have to find, we will process them separately. So how we can find the number of square numbers less than equals to n? Okay, so the number of square numbers less than equals to n is nothing but square root of n. Okay, the number of square number less than equals to n is nothing but square root of n. Let's take one example. For 10, the square root of 10 is nothing but 3. If we take the integer value, then we can say 1 square, 2 square and 3 square are the square numbers which are less than equals to 10. Okay, so our answer will be initialized with the square root of n, and after that we'll process all the other values from b equals to 3 till 20. Okay, or 3 till log of 10 to the power 18, you can say. But here is a case that some of the square numbers are repeated in here also. Let's say if we take if we take 100 yeah, 100 square is 100 cube is nothing but 10 to the power 6. This will be same as 10 cube, square. Okay, so here you can see that let me take one moment. Yeah, let's jump back. So we are taking power of a square number. This will be obviously be a power square number. So we can't really take any square number and take the power of the square number. This is one case, and another case is, let's say we are taking 10 to the power 4. Okay, we are taking 10 to the power 4, which is nothing but 10 square is square. So the two cases, the other two observations, the second and third observation is that we can't take square numbers. This is the second observation, and the third observation is that we can't take even powers. That is the case. Now we will jump into the code. You will understand it better. Here, for finding the square root of n, this was giving me wrong answers when I am taking the square root of n and taking the integer value of it. I am not sure which test case it was failing. So instead of that, I think it is something, let's say 99.9999, and it is taking integer value of this as 100 or like that, something like that. So you can do find the square root of x in log n time, and square this will give us the maximum value. Square root of x is the maximum value such that s into s is less than equals to n. It will give us the value of this. We can do it in order of log n using binary search. You can check that out. It is quite popular problem. Okay, now what we are doing, we are marking all the square number less than equals to 10 to the power 6 here by visited of I into I as 1. We are marking all the square numbers less than equals to 10 to the power 6 in a visited array. Now we are taking answer as square root of n. In this binary search approach, we are not using any square root function in the code. Okay, now we are taking I as 2 while I cube is less than equals to n. If I in b, this means this is a square number. We are multiplying I plus equals to 1 and we are doing continue. Okay, now we are taking p equals to I cube. So we will take only the odd powers, right? We will take 3 power as 3, 5, 7 like that, and we are taking square as I squared. So we at each step we multiply p by square. So we'll, after the first step we will get I to the power 5, and after the second step we will get I to the power 7 like that. Okay, now while p less than equals to n, if p is not visited, we are marking this as visited and we are doing answer plus equals to 1, and we are multiplying p by s cube. Okay, and at the end we are printing the answer. The total time complexity is nothing but 10 to the power 6 log 10 to the power 6, which is possible. For C++, I think you have to handle this case. I think there will be some handling for integer overflow. You can check any C++ accepted code for that, but the overall idea I think will be same. So if you got the explanation, you can like the video and subscribe to my channel. If you have any doubt in any part of the explanation or code, you can always ask in the comment section. I will provide the link of the code in the description box. Please share the video among your peers. Thank you.